Section 8.2, example 3, finding the equation of a hyperbola centered at HK given its foci and vertices. So what is a standard form equation of the hyperbola that has vertices at 0, -2, 6, -2, and foci -2, -2, 8, -2. All right, let's see. I'd say let's start by graphing it. Because at this point, we have two possibilities. We could either be in the form x minus h squared over a squared minus y minus k squared over b squared equals 1. Or we could be in the form of y minus k squared over a squared minus x minus h squared over b squared equals 1. This one here, remember we graph on x, not on y. So this is going to be in the form of this right here. This one here, we graph on y, not x. That one's going to be in the form of something like this. So let's see what we have right now. Let's start up here. All right, so starting off at 6, -2, we have 1, 2, 3, 4, 5, 6, -1, 2. We have that value. Oh, I gave this one. Let's do 0, -2. All right, looks good. Next, let's do -2, -2. That's this one here, and another foci at 8, -2. All right, so from here, it looks like our major axis is the x-axis. Our graph looks like this. So we're graphing on x, not y. So graphing on x, not y. So that means that we could say no to this one right here. So things that we need, let's see. X minus h squared, a squared minus y minus k squared, b squared equals 1. Let's figure out what the center is. So center we could get from the center of our foci or from the center of our vertices. Doesn't really matter. Let's do from our vertices. So finding the midpoint, we have, so from the vertices, these two right here, 0 plus 6 divided by 2. And from these two, -2 plus -2 divided by 2. Plus -2, and we're dividing that by 2. So here we have 6 divided by 2 and -4 divided by 2. That's 3, -2. So we plug that in to our equation here, and let's see what we get. X minus 3 squared over a squared minus y plus 2 squared over b squared equals 1. All right, we have that. We also have the distance from the center to our vertices now that we have that. So we have 1, 2, 3 over here. So we went 1, 2, 3 units to our vertice, and we went 1, 2, 3 units to that vertice. So we know that since the distance here is 3, since the distance there is 3, we know that a in the x direction, because we're moving in the x direction here, it ends up being 3. So x minus 3 squared over 3 squared minus y plus 2 squared over, we don't know that one yet, but equals 1. So we have to figure out this part here. And we could easily figure that part out by seeing the distance again. So we went out 1, so from the center, 1, 2, 3, 4, 5 units there. 1, 2, 3, 4, 5 units over here too. So in our equation, c is equal to the square root a squared plus b squared. We know that c is 5. So 5 is equal to the square root of a squared, which is 3 squared, plus b squared. We could use this equation here to figure out what b is. So let's start by squaring both sides. So we have 25 is equal to 3 squared is 9, plus b squared. B squared ends up being 16. And that's it. Because what we actually need is b squared. I mean, we could take the square root of 16 and figure out what that is, but we're just going to have to square it again. So we could just leave that as 16. And let's simplify it so we could finalize everything. So from here, we're going to say x minus 3 squared over 3 squared, which is 9, minus y plus 2 squared over 16 equals 1. There we go. If you have any questions, please feel free to ask. Otherwise, bye.